Okay. So, welcome everyone. Welcome to today's discussion. So, we are going to talk about an AI edge inference using the Executorch. Now, before we deep dive into what is Executorch and what is quantization, Hugging Face, Android, as we all see on the slide, I need to bring everyone on the same page, and we should set up the background correctly here first. So, in a layman term, what we are going to do is we are going to talk about how the capability of any AI model or any AI chatbot or per se simply any AI utility, say a GPT, how can we bring in the same thing into a mobile phone? And what's the need of doing that? Why we need to do that? What we are gaining out of that? So if we break this answer into two, we segregate into a common user terminology, how it's going to be beneficial, and technical or and executive level also. So starting with for any layman, like consider if we are going to use a supercomputer, we need to buy it, or consider simply a GPU, we need to buy, we need to host it, we need to do the maintenance for that. How about we need not to do all those things, and simply everything that GPU is going to do today is done in your mobile phone that you already have. Means you're not going to bring in any operational cost. You're not going to buy anything new. The same capability that you would be getting in CPU, you are getting into your phone. And for the executive, we can put it like this. For any model at a scalable level, at enterprise level, if you want to run, we need to have a GPU. GPU itself is nothing but a composition of thousands of CPUs. So it doesn't come for free. Using GPU itself has a lot of charges. Now, how about the same thing can be deferred to client side? Client herein, I'm referring to any edge device. Edge device could be mobile phone, your laptop, or any IoT device, maybe robotics, to be very specific. But here we are talking about mobile phone. So the agenda is to understand how much feasible it is to bring in the same capability at low the cost directly into your Android phone with having a minimal capacity, the minimal GB of RAM. So we'll be talking about that pipeline. Now, what we gain from that, why we actually need to do. The reason being, consider any bank or any organization per se, they don't want to send their data outside over the network. There's always a security issue. How about we keep it on premises? But we don't want to invest time on the GPU itself. Rather, we just want to put everything in the phone. Phone is with the authorized person. It won't go out of over the network. So the data sovereignty or data privacy, that's one thing we are handling. Latency is the second major thing we are handling. Now consider the case of any fraud detection, wherein that any request that coming in, that the agent or the AI tool need to predict whether transaction is a fraud or no. It has to have a minimal latency. Now, if nothing is going over the network, everything is being done on the phone, the latency is the minimal. So that's the major gain that we'll have. So just to reiterate, we can put it like, rather than deploying anything, rather than having our dependency on the cloud and maintaining the cloud, we'll have everything pre-compiled, composed, so that it can fit into our phone itself or any other memory constrained devices. So illustrate for the illustration, we have taken the phone here. So without wasting much time, let's hop on to the detail. Now, how do we visualize this pipeline? The pipeline basically is consisting of the 5 different stages. The very first stage would be the model compressor. That takes a plain raw PyTorch model and it applies a quantization. That's int 8 or a FP16 quantization, and the output is a .pt file. That is something that can be executable and can be shipped to Executorch runtime. That's a prerequisite of Executorch runtime that we are going to run on the phone itself. Now, the other step in the pipeline would be, once you are done with the creating your model, compressing or quantizing the model, you will be putting it to the Hugging Face. Hugging Face is something you can, for the analogy, we can take it something like Docker Hub or GitHub, where we all have our repo. Similarly, in Hugging Face, we can create our repo. And we'll be putting up the file, .pt file that we've just generated in the first step using the PyTorch file in that Hugging Face repo, along with its tokenizer.bin. Now, what's the tokenizer bin? That we'll be talking about in the forthcoming slides, but to get a high level idea, tokenization bin will be a binary file that know how any query that would be fired against the phi3 model should be interpreted and converted to numerical representation. Why is that needed? Because model will not understand the English. Model understand the numbers. So it's something you can say a bridge that will convert a text to number, and how it should be converted that would be defined in that binary file itself. So we'll be putting two things in the repo. That's a PT file generated in step 1 along with the bin file. Now, the third stage would be once we have uploaded the PT file and the bin file, will be opening an Android Studio. That's one of the ID for the Android development. Now, the point is why we are putting it to Android Studio, because it itself is a 2 GB of more than 2 GB of its memory footprint, and building that along with the studio will be like something not a feasible task. So what we do, we will be referring that endpoint, the Hugging Face endpoint where our model is hosted, and at the very first time when building, it will refer to that and it will build a corresponding APK file. So moving on to the next one, once we are done with the build, we'll be getting one APK file generated. And the same thing we can validate on the emulator itself that we'll be seeing in the next slides. And eventually the fourth agent is something that should be able to make a Wi-Fi bridge. That is nothing but simply we have to enable our phone into developer mode and then connect through wireless portability and use the port specified and do the pairing based on the port based on the IP, and we'll be able to connect. So the basic it's a very easy part actually. We have to just rerun the build by selecting our phone that's connected. And once that is done, we'll be seeing a pop-up on our phone to install, and we'll be able to run the app itself. So it's like a mini GPT in your own Android phone. So eventually it concludes with the step of app running on your Android phone. So let's hop on to the what exactly the steps we are doing in detail here. So first of all, we'll be having an Executorch file would be generated. So how it would be generated? It would be generated by creating a Python file. The Python file would be referring the PyTorch and other dependencies. And eventually when it will build, it's simply a Python run command, and it will conclude by generating the .pt file. So before that, we need to understand what exactly that script is going to do. We'll be showing that script in the next slide, but I'm just trying to build up, walk through what exactly going to come in that file. So consider a Python file. Maybe I can share it here itself. Okay, so this is how this file looks like. It's simply a create pt file. So here the name conventions are different actually. Yeah, I'll be updating it soon. It's like we can take it, create pt file. So this is the file you see. It's a Python file. So when we run this, we just simply need to run using your selected virtual environment. And then using the Python version, we are using 3.11, and we'll be simply creating a Python file. So what exactly do? You see the very first step is it's going to download the model weights. How it's going to download? We have specified here the model name itself. You see here. Yeah. So it's loading the weights here and quantizing here. If you see the step 1. Yeah. So first of all, it's checking for the memory, how much memory is required, the pre-check, the validations. And post that using Hugging Face, it would be downloading the file and it will checking for the corresponding weights. What we can see here, P3 weights, these are the weights, model weights. So when we say weight, we can visualize like something, the component, the base component for any model that are being used to train a model so that it can do the prediction for the forthcoming user queries. So all those gets downloaded here. So if you see in the log itself, it's very clear, like it checking for free space. Okay, it has 10 GB. 9 GB was the minimal, we have kept it. So what it all do, it download the relevant file. Since I've already run, so we are seeing it's already existing. So eventually it download all the required files and model files and the tensor files, and also a JSON file that we just talked about, the tokenizer JSON that defines how the model will do the interpretation. And it also check for the verification. If you see the model version, we are using 1.2 for Executorch. And there are some patching to be done. It's more like you can visualize whenever this file is running, it's creating a, we can develop a mental model as if like it's creating a graph representation that will be eventually compressed and saved into .pt file that will be inflated when it will be running on the mobile phone. So it's a graphical representation. So all this thing would be done, and eventually we see it will apply the quantization. How here it's failing, probably I have changed some configuration later on, but this is how the quantization would be. And quantization means we are interchangeably talking about quantization as a compression, compressing the 2 to 3 GB of model to 900 MB. Now, if you see here, whatever we have just walked through, this I'll be putting on my GitHub link. So this is the detailed Python file. Now we'll just understand what it's doing functionally. So this pipeline ensures the weights that we just talked about, the component of the model to get copied, should be downloaded in the in your system or maybe the laptop where you're working. It will do the apply the patch on top of that model that's required as per the quantization, and it will be using ADA4W quantization. Means it will be doing the dynamic quantization at activation side and static quantization at the model side. So we can visualize like we can compress the models or activation, either way. This is one of the implementation of quantization. We have different provision, and based on which quantization we apply, the precision might have a difference. To keep it simple, I've just used a one that's where the models are static, and dynamic quantization done for the activation part. And eventually, it's serialized to PT file that is expected by the Executorch runtime. So now the Executorch runtime is something, the crux of the whole thing, because this is something that makes feasible to run the quantized model on any phone basically, or the memory constrained devices. So here are some of the command highlights, like what exactly the version we are using. And yeah, so once this is done, you'll be getting the PT file. Now, once the PT file done, as we just talked in the previous slide, like after PT file created, we need to upload it to the Hugging Face Hub, something equivalent to Docker Hub. These are the command we'll be using. I have created one repo there under the Hugging Face CLI. The only thing is like we might not have a write permission or read permission for the Hugging Face, but we can simply go to huggingface.com and raise a request. Within a span of a day or so, we get approval generally for lightweight model, what I have tried for. So we can simply create a workspace and put the models there. So this is one of the command I've used to upload. First of all, we'll be creating a repo, then uploading a PT file, then uploading a JSON, tokenized JSON file. And now, okay, now since we have uploaded to the Hugging Face, what is the next step? Just we'll go back. We are done with the first two steps. We are coming to the third one, where we'll come with the Android builder. So this is how the Android builder looks like. Android builder structure is something like this. It's an Android Studio. The structure, like under the app, will be having SRC. It's a template basically. Underneath, you need to, if you have small model, you can put it on under assets. But since it's a heavy model, so what we are offered is, we rather than putting into local, we are using downloading it at the very first time when it will be built, and subsequent build it will not be downloaded, since it will check for it's already existing in the local. So one thing that I have skipped here, like my Hugging Face token, that is something I should not expose. So this is something we should be adding whenever we are building. This code also I'll be putting into the GitHub. So coming back to what exactly this agent will do. Now in this structure, what basically we are going to change, we are going to make a change to this main.activity kt. It's a Kotlin file. Then we'll have a chat messenger and message and adapter. Adapter is something that will be looking for at the runtime whenever we are putting a question to the prompt. It will be streaming the token and it will be giving you the output. That will come to that stage later. But the point here is to talk about how this agent will eventually work. So if you see here, we'll be using base model where we have uploaded the model, and this would be used basically. If you see here, whenever we are building that uh, this app, basically we'll be building simply like this. It will be a Gradle build. It's a Gradle build here. In build.gradle build, we would have given some dependencies at global level and also at the app level. And then at the app level, we specify what dependencies are needed, like GNI library and Android basics. So once this is built, if you see here, we'll get a logcat logs that will give you what exactly it's building for. For instance, if you look here, we'll have first say this one, if you see. So whenever model will run, it will look for the model path where it's getting stored. It will look for the size of the model. This is the size of the model it's loading, 2 GB now. And it will be tokenized. This would be the path of the tokenizer. And this would be eventually used and will be pushed to your mobile phone. Now, this is how the structure looks like. Now, if we talk about the purpose, so from the file structure, as I said, for UI and UX, we have a chat adapter and that file created. And download manager will be used to fetch the large files. And eventually, after loading, we'll be using this is the code from the Kotlin basically. That is something can be further optimized actually. How we are going to, how we are going to pass, how we are going to load the token that's getting generated. This is something open for improvisation. But the point here is, like, once this is built, and the next agent would be pairing, maybe using QR code or using pairing code. And once we run it again, we'll be seeing the model getting downloaded in the phone like this. And once it's not found, okay, it will download that from the Hugging Face. Just need 2 GB of from the Hugging Face basically, and you can ask him whatever is required. It will give you the answer accordingly. Now, uh, if you look here, the integration and is something that's very relevant. So I think this is good enough for us to have a walkthrough, but the primary agenda was like how a model, something that is already pre-trained, we can put into Hugging Face and could be compressed and put it to Hugging Face, and we'll be pulling it same using Android, and we'll be putting into our mobile phone. And in case if we want to have a live demo, I can show you my phone itself. But this is how once it's deployed, how it looks like. P3 Mini would be ready. It will load once time and you can ask and it will give you answer. So basically, the idea is right now we are using Pi 3. Now consider if you have our in-house development being done or in-house model or wrapper model, and we want to use it, but we don't want it to be hosted outside. The same thing can be used. We can just use that base model, quantize that, put it into Hugging Face. That's something of our own account maybe. And once we pull it into our mobile phone, we can get rid of the hosted on the cloud. And yeah, and we can run the model within our phone without need to have a network communication. And yeah, it's easy to go. All sovereign data, no network latency is there. Latency is also in real time. And the only thing, like in this particular phase, we just talked about how we can deploy the model. Rather, what we are going to do in the subsequent discussion is we are going to understand how we can we can train the model itself using a fragmentation training. So I hope this makes sense. Probably I just want to show one more thing here. This one probably I just missed it. Okay, so I have some thing defined here. So this is my QR code. You might scan it, and for my YouTube channel, I'm going to host subsequent discussion on this one. Please do let me know if any queries. Can put into my LinkedIn. You can approach me on LinkedIn. I'll try to improvise it further. Thanks for being there, and thanks for attending the session, and have a great day. Thank you.